So what are these cumulative columns that I mentioned earlier? Well, remember we're dealing now with an ordered variable. That means ordinal, interval, or ratio. So those values that we're seeing there, 5, 6, 7, 8, 9, and 10, they are in the real order. So we can talk about one value being lower than the other one. So what we can do is the following. We're going to add two more columns, and I'm going to explain to you what those numbers are. Now, notice that the first value, the lowest value, 5, has a frequency of 4, and the cumulative frequency is also 4. Now, if we look at the 5 and 6 values combined, they have a combined, therefore cumulative frequency of 16, and that is the number that goes into cumulative frequency. In the same way, if you look at the percentages, the percentage for 5 and 6 were 10 and 30. You add them up and you get the 40, which is in the cumulative frequency. Similarly, if we look at the first three, they add up to 22, and that's the 22 that you get in the next at the next level. So each one of these cumulative frequencies indicates how many times a value as big as the one in that row or lower was observed, or its percentage. And of course, same, we can keep going. We can do the first 4, it will be 23, or we can do the first 5, it'll get a 25, or we'll do all of them, in which case, of course, we get a cumulative of 40, which was the sample size. Now, if there are too many values, let's say that we have an ordered variable with very many values, what we can do is we can try to group those values. So what we can do is we can make a cumulative table by combining the frequencies but keeping the original data. So we would end up with a table that looks like this. So for instance, let's say we combine the values 10 and 11 together. They had a frequency of 3, meaning they were observed 3 times, either 10 or in 11. If we combine 12 and 13, then we end up with a frequency of 8, and so on and so on. So I'm emphasizing here that you can do exactly the same thing as with individual values by grouping it. Of course, I'm grouping it in a very small way here, 10 to 11, but we could go anywhere 10 to 20, say, and 21 to 30 or something like that. However, it is very important to keep the original data, because this is just a way of organizing data so that we can make sense of it. And we're starting to summarize, notice that, but we have not yet summarized as much as we will in the future. Now, sometimes there are two variables that we observe at the same time on each member of the population, and we want to combine the frequencies. So what we do is we're going to use a contingency table. So this is a table that is used to record frequencies for two simultaneous variables. For instance, let's say that we're looking at two variables. One of them can take values A, B, C, D. You can assume it's nominal or ordinal. And another one can assume values 1, 2, 3. So let's say we observe a number of members of the population, or members of the sample. We take a sample, to be more precise, and for each member of the sample we observed both the A, B, C, D variable and the 1, 2, 3 variable. And let's say that we have two people who scored 1A. So we're going to put a 2 in the corresponding cell. And then we're going to have two people who scored 2 and A, and then 5 people who scored 3 and A. So for a total of 17 people who scored A. You can do the same thing with the B's, and of course with the C's, and with the D's. And then we can also consider the totals for the values of the other variable, 1, 2, 3. You can see that in total 7 people scored a 1, 27 scored a 2, and 31 scored a 3. Now you might wonder, where are these totals coming from, and do we really need to worry about them? And yes, you do, because these totals will be used later on in certain other kinds of analysis. And therefore it's important when you have a contingency table to add also the totals of the rows and the totals of the columns. Now, contingency tables for some people are only limited to situations where the two variables, each of those two variables we're looking at, only have two values. So when we're dealing with dichotomous variables. But in fact, there is nothing preventing us from using them even in situations where we have variables with several values.